Welcome students. Now we are about to start a neat question regarding the oscillation. Here the oscillation, a neat question and its answer. Let us start with the one that is first MCQ. I am going to read that here. The distance covered by a particle undergoing simple harmonic motion in one time period is, in bracket, amplitude is equal to A, and first option A is A, that is 2A, B that is 4A, C that is 0, and D that is A. Let us explain how much is the distance and what is the answer of that. Distance covered by the particle performing simple harmonic motion is explained using this diagram. This is given by here. I am going to draw one line over which we have the simple harmonic motion. It is takes place. This is the straight line over which I am going to take. If this is the mean position, this is your mean position, this is your extreme position, this is also extreme position. We can term that as an extreme, this as a mean, and this as a once again we have the extreme. Now from mean, if the particle starts, what may be the, maybe it may starts from extreme, it may starts from mean, but it may complete one single oscillation. During that one, here is the path. If it starts from the mean position, x is equal to 0, and from that one the distance it is covered is equal to this much, that is, here it is. So this is the distance which is covered here. Here is the distance which is covered from mean to extreme. Again it will goes from extreme to mean, and this is the distance which is covered. Again from this mean to extreme it covers this much of distance which is given by here. Again from extreme to, again we have the mean, it will cover this distance. So this distance which is covered during this process, I am going to consider this is the distance which is covered, that is, this distance is A. Again this distance is A, amplitude, maximum displacement of the particle from the mean position. Again this distance is A, and this distance is A. Total distance cover is equal to A plus A plus A plus A. That means total distance cover is equal to 4A. What about the displacement? That we need to get the idea about. Here the distance cover is 4A. I'm going to cleanly write that 4A. What about the displacement? Displacement is a distance cover in a straight line from one position to other position, but the distance cover, if it starts from mean position where x is equal to 0 and here x is equal to A, the distance cover from x is equal to 0 to A, again from A to 0, that means displacement is 0. We will have to remember this fact, that total distance cover is equal to A plus A plus A, and total displacement is equal to 0. That we need to remember. Now come toward the next MCQ. Here it is. The average velocity of the particle executing simple harmonic motion in complete vibration is A option A omega upon 2, B option A omega, C option A omega square by 2, and D option it is 0. As previously we know, the velocity is equal to displacement upon time. Displacement upon time. Time taken by the particle to perform simple harmonic motion in, we say, SHM. But during in SHM we know displacement, okay, in one oscillation is equal to 0. So velocity is equal to 0 divided by that distance, or we say time, displacement upon time, which is equal to 0. So we have the answer, that is 0. Okay, now come toward the next, and this one is the we say third one. Let us get this third one. See this one. What is this? I am going to read that one by one. Here, the displacement of the particle executing simple harmonic motion is given by y is equal to a0 plus a sine of omega t plus b cos of omega t. Then the amplitude of oscillation, it is given by the option A is a0 plus under root of a square plus b square. Second option under root of a square plus b square. Third option we say under root of a square plus we say under root of a plus b whole square. And the fourth D option we need to consider, that is under root of a square minus b square. If such a question, if it is asked in exam, then what is the solution of that? That is the most important one. See, observing all the facts, if we need to get the observation here, I need to consider all the options, but resultant we need to consider. The given equation, it is given by y is equal to a0. In that one, this a0 is a negligible fact because it is not the part of that we say simple harmonic motion, but this equation is a simple harmonic equation. So a sine and here the cos, means obviously we know sine and cosine, we have the resultant displacement. So resultant amplitude equation, it is given by under root of, here it is a1 a square plus b square plus 2ab cos of theta. Theta means phase difference between these two. As we know, sine and cosine, okay, between cosine and sine, between sine and cosine wave phase difference is 0. Phase difference is 0. Phase difference is 90 it is. Why? Because sine is starting from the 0 and cosine is starting from the 90. Phase difference is 90 degree. So if it is 90 degree phase, then resultant wave, it is given by a is equal to under root of, here it is a square plus b square plus 2ab cos of we say 90, and as we know cos of 90 degree is equal to 0. Cos of 90 degree is equal to 0, and a is equal to under root of, we say a square plus b square plus 0. That means answer is under root of a square plus b square. Then which option it is correct? Then this option it is correct. Okay, this option is correct. Now then come toward the next. Which option it is correct? B option it is correct, under root of a square plus b square. So we have the fourth but most important one, because it is though it is complex, but we'll have to remember this what exactly is the solution for that one. Okay, this is the most important one. See, here it is. A particle executing simple harmonic motion along a straight line, its velocities or displacements at x1 and x2. From this mean position, its velocities are given by v1 and v2 respectively. Its time period is how much? Then we have these options, and that is a and 2 pi under root of x1 square plus x2 square and divided by v1 square plus v2 square plus, and then next we have this b option, that is 2 pi under root of x2 square minus x1 square divided by v1 square minus v2 square. C option, 2 pi under root of v1 square plus v2 square under root of we say divided by x1 square plus x2 square. And last option, that is d 2 pi under root of v1 square minus v2 square upon x1 square minus x2 square. Then which option it is correct, we will decide. Okay, let us start. Before that one, we have the displacements x1 and x2 and their respective velocities are v1 and v2. So we know very well that v1 and v2 are the velocities of the particle at different positions. Then we have this solution. We have the v1 is equal to omega into under root of, here it is, a square minus x1 square. Why? Because regarding this v1 we have the displacement x1 and we have this v2 is equal to omega into under root of a square minus x2 square. So this is v1 and v2. So we need to get this v1 and v2. These are the two equations, equation number 1 and equation number 2. If we subtract equation 1 from 2, then we have the equations, that is v1 minus v2 is equal to omega into under root of, we say, a square minus x square minus omega into under root of, we say, a square minus, or we say this is the first one, that is x1 square, and this is the x2 square. See, this is the equation for this x1, okay, and this is the equation for, we say, v2, that is respective x2 is the displacement. If we square both the sides, if we are going to take this v1 square, v2 square respectively, so here it is omega square into bracket a square minus x1 square minus omega square into bracket a2 square minus x2 square. And later on, if we consider, or we are about to multiply this omega square throughout the bracket, omega square a square minus omega square minus x, we say, into x1 square minus omega square into a square, minus minus become plus, here it is omega square into x2 square. If we need to rub this one, I will repeat this one. See, omega square okay, omega square into x1 square. Okay, now this is the equation. Later on, if we observe, these are the similar terms get cancelled. Only the remaining term is omega square. This is the plus term. We are taking to the, we say, this side, x2 square minus omega square into x1 square. Okay. Then if we take omega square common in bracket x2 square minus x1 square, and as it is we have this v1 square minus v2 square. If we need to interchange the position, that is omega square, then as it is this divided by, means v1 square minus v2 square divided by x2 square minus x1 square. Then we have this, we say omega is equal to under root of, we say, v1 square minus v2 square divided by x2 square minus x1 square. But we know that omega is nothing but your 2 pi upon t, and 2 pi upon t is equal to equal to we say under root of v1 square minus v2 square divided by x2 square minus x1 square. Take the reciprocal of this term, that is t upon 2 pi is equal to under root of x2 square minus x1 square upon v1 square minus v2 square. Then the final answer that we got is that t is equal to 2 pi under root of here x2 square minus x1 square divided by v1 square minus v2 square. This is your final answer that we got. Okay, this is your final answer, and hence we got the option. Which option it is correct? That is B option. It is correct one. Okay, this is all about the solution regarding the 4. At least we have taken the 3, and then next we are going to take the 4th one in next session. Thank you.